Welcome. I'm happy to say that my book sold out. Thank you very much. Yeah, there were only 2 books though. Straight after the lecture, well, or yeah, because I bought some. Okay, you got me. I don't. Well, I'll tell you a little bit about me. My name is Roy Osherove. I have a blog at iserializable.com. I work at a company called TypeMock. We're actually going to see a little demo of some of the tools that we make because they're considered isolation frameworks, part of the frameworks that I'm going to show. You can also follow me on Twitter, Roy Osherove, and I'm hoping to get some new Twitter followers who can listen to every little stupid thing that I say. Now you can only get this book on Amazon. Is there like an Amazon.no? Is there? No. Amazon.no. Okay. This is the 4th part in the series of how to be better. That's how I think about it. How do we as developers get better? We make promises to ourselves and we learn stuff. So thank you for coming here to learn. When people start doing unit testing, they only see the simple demos, the simple stuff, and then they get into real world scenarios and they get stuck because things become difficult. Sometimes the code is hard to test. Sometimes there are concepts that are hard to follow in the beginning. Mock objects was one of the things that was really hard for me to grasp in the beginning. In fact, it was quite scary. I don't remember quite the moment that I actually got it, but I hope that you're going to get that moment today because it's a pretty simple concept, really. Just a kind of a scary name as far as I'm concerned. The next 2 talks are going to be a bit on the edge. There are things that I've not seen done using unit testing and the whole idea of system level isolation, so they should be interesting. But they do require specific amount of knowledge in unit testing. If you feel that you're comfortable with unit testing already, they should be comfortable for you. Thank you. Okay. We're going to talk about several concepts first. Mocks versus stubs, the differences between them. I'm going to show how you can create them in a handwritten manner, manual mocks and stubs. We'll talk about the differences of when you would want to create the manual and when you would want to use isolation frameworks or mocking frameworks, as people like to say. I specifically dislike the use of the word mocking frameworks. I think the word mocking is overloaded as it is. It means too many things. And as you'll see, mock does mean one specific thing technically. And when you use it for other things, you confuse people. And best practices, or should I say worst practices with mock objects. So those of you who have seen simple unit testing scenarios have probably seen scenarios where you invoke a method, you get back a return value, everything is great, it's perfect. This is a scenario that's a little more real world, if you will. It's a scenario where you have, let's say, a class called storage. It has an email sender that's being given to it, let's say using a constructor, or maybe it's creating it hard-coded, create a new instance and works against it. It has a public void method, does not return any value, that takes some kind of object. Now, let's assume that our rule that we want to check, the requirement, is that if the object has a specific property, that's true, then it should send an email using the email sender. So the requirement is, if I call save with a specific object, then it should send an email using the email sender to a specific address with a specific message. That's usually a scenario where people who start doing unit testing break down because there is no return value. So they start thinking, how do I test that it calls the email sender? Or how do I test that the email is actually being sent? So if this was a simpler scenario where I would say it writes to a file on the file system, some people would write a test that says call save and check that there is now a file on the system with this specific contents. Not a bad idea. But it is not a unit test. It is an integration test. Let's define the difference. A unit test, for me, is anything that runs only in memory, runs fast, is repeatable, and does not touch any external resources. So if it touches a database or a file system, it's not a unit test. And the reason we need to differentiate between them is that once you touch an external system, in this case, it touches an email. But in the previous case, it touched the file system. Then you are contaminating an external environment where other tests also have access to it. So it's harder to roll back all those changes. It's harder to isolate those tests. And we want to separate the idea of integration testing because you're testing not just your code, you're also testing some third-party code, like the database, or like the email sender, or like the file system, the thing that writes to the file system. And you're essentially dependent on that third party. Here you are dependent on the email actually being available if you want to check that there's actually an email somewhere in some inbox. With a file system, you're dependent on the file system. If the file system is maybe too full or there's garbage there from other tests, you're going to have a problem. We want tests to be simple and easy to run so they're repeatable. So in this case, if I wanted to check that it sends an email, one option would be to actually connect to an external email server and check that there's a message in the inbox. Of course, this is a problem. First, it will take too long. Second, everyone who wants to run this test now needs to have an external email server running and configured just to run this simple test. We don't want that. We want tests to be under our control. So one thing we can do is just say, hey, I don't care what email sender does. What I want to test is just the interaction between class storage and the email sender. So if you think about it, I just test this interaction, this red line. This is what I care about. So the test would call save, and then would check that email sender was called, but it wouldn't actually call email sender. That's what I'd like to happen. Now, to achieve something like that with .NET, I can extract an interface so that I can replace the email sender with my own email sender. So in my production code, I would create a new interface. And that interface would have a method called write or send email or whatever. But now notice that the class storage, in this case inside the constructor, will take an interface. It doesn't know if it's a real email sender, if it's a fake one, or whatever. Now because there's now an interface in the production code, I, in my test code, can implement that interface, create my own fake email sender. Now this fake email sender, because I can send it through the constructor, I can now initialize an instance of class storage with the fake email sender. Now because it looks exactly the same, the class wouldn't notice. But the trick is that because this is part of my test, I don't really have to implement any email functionality. I can implement just empty methods, maybe just save the values that are sent into the methods. Save them as public fields, for example. It's part of my test, so I can expose whatever I want. It's my own class. Just implements an interface externally. And then in my test, I can actually assert that the methods that were called on fake email sender were sent with the correct parameters without actually sending an email. So in this case, I'm using fake email sender to replace an existing object. It looks just like that object, but I'm using it because I'm saving the values that are being sent to it, to the methods. So actually, my test will assert against that fake object. Now, in technical terms, when you have an object that it fakes or implements another object, but it decides if your test passed or not, in this case it will decide if it passed or not because it holds all the data that I need to decide, then that is called a mock object. A mock object is a fake object that is inserted into the system and later is the one that helps me decide if the system indeed interacted with some other object. So it's just a fake thing I send in and I assert against it. If you send it in and you assert against it and it's not against the real system, it's a mock object. Now notice that I use the word interaction, and when we talk about mock objects, we are actually entering a new territory called interaction testing. When you're testing interactions between systems, what you care about is just the calls. You don't care about the other systems. So you would use mock objects to check the interactions against them. Let's see how that actually looks in action. Let's move this over here. I'm sure you guys above don't have any noise next to you, right? You can hear everything. New updates available. Thank you. And I'm not even connected to the internet. That's amazing. I think it's a mock internet. Okay. Let's just take a look at the structure here. I just have a bunch of demos to show. This is a demo that kind of looks like what I just explained. We're going to have a login manager. That login manager has a function called isLoginOK. And what I will want to test is that every time isLoginOK is called, it writes to a log file, which is kind of like saying it sends an email. So the interaction here would be, if I wanted to test a specific piece of code, let's look at how it works. The login manager with the mock object has a constructor. The constructor is very simple. It takes an interface. And notice that I actually had to change some of my design to make this testable, as far as I'm concerned. I extracted a new interface into the system and so on. It just saves the logger. And later, in the isLoginOK, this is the interaction that I want to test. Let's assume it's very simple. Every time isLoginOK is called, then the log is written. Every login is being logged. How do I test this interaction? In my tests, I can do something as simple as this. I can create my own class called fakeLogger. Notice it implements the same interface, but because it's part of the test project, it doesn't have to adhere to the same rules. It doesn't have to do anything. In this case, I tell it to do what I want. It just saves the message that's being sent to the method, and then I can later assert against the message that was sent. This is a simple test that uses that manual mock object. So in my simple test, let's just look at the name just for a second. isLoginOK is the method under test. When called, that means every time it's called, writes to the log. That's what I want. So we have, I create a new fake logger in my test. Notice that I actually use it as a fake logger, not as an iLogger. And the reason is so that I have access to the public field later in my test. But for login manager with mock object, I can hear Allende from here. And for login manager with mock object, I would just send it in to the constructor. I create the fake, I send it to the constructor. Of course it works, it implements the interface. Now, this is the act part. I invoke the method, and this is what the assert looks like. I'm checking a field on that manual mock object. So I know it's a mock object, not just because I gave it a name, because the name can be misleading. Because the assert is not against the real code, it's against some fake object that I sent it. Anyone want me to repeat this? Just raise your hands. Don't worry, it's okay. Some people don't get this the first time, and it's really important to get this first one right. After that, everything becomes easier. Anyone want me to repeat this? Okay. Whoever is too shy to say that they want me to repeat this, raise their hands. Okay, never mind. So that was a mock object. Now let's look at something a bit more interesting. Now I have a different requirement. That other requirement works. Now I have a requirement that says, look, when you try to write to the log, in this case, when you try to write to the email, and the email fails, I want you to write to the log. And in our case, it means that I need now that the fake email sender that I created earlier, I needed to actually send an exception. So of course, I need to somehow test the interaction. But the question is, which interaction do I want to test? The requirement is, when trying to send an email and you get an exception, you should be writing to the log. So the end result is what? I'm not continuing until I hear an answer. An entry in the log. Well, an entry in the log is an end result for real. But for my test, the end result should be just the call to the log. Okay? There should not be really an end result, like an entry in the log. There should not be a real log as far as I'm concerned. So I'm just testing the left arrow. But I still have this fake email sender that I probably want to send, because I don't know how to simulate an error from a real email server. Let's say I want to simulate that the server is full. Would I need to actually fill the server with email messages so that this test would pass? That's a bit crazy. And sometimes this is exactly the problem. You cannot simulate some situations without faking things. Let's say out of memory exception and so on. So if the email sender throws an exception while sending an email, you should be calling the log writer. So where would the assert be? The assert would be against fake email sender or fake log writer? Come on, you know this. Fake log writer. So which one is the mock object? Sorry? Both? No, not both. The assert can only be on one of them. So which one is the mock object? The log writer is the mock object here. The fake log writer is our mock object, because we're only asserting on one of them. So what does that make the fake email sender? The fake email sender just helps us run the test. We're not asserting on it. So that is called a stub. So the thing that you assert on is called a mock object, logically. And everything else that just helps the test run is a stub. You can have multiple stubs just to make the test running, right? You need an email, you need a log, cache or whatever. But at one point, you're only going to assert on one of them, and that will be the mock object. If you have more than one mock object in your test, you're probably testing more than one thing. You only want to assert that one interaction happened. That's one end result. Most of the time, there are always exceptions, but if you see more than one assert on different mock objects in one test, it's usually a test smell. So in this case, that same fake email sender that I used before as a mock object is now being used as a stub. And I'll show how you can make it throw an exception using manual stubs. And now that log writer will be used as a mock. But in other tests, I can use those same classes the other way around. So that fake object can either be a stub or a mock based on how it's used. And that's the basic, simple idea. You create fake objects, and based on how you use them, they are by default stubs until you assert against them, and then they become a mock object. That's the default idea. Let's see how I would recreate that same thing where you have one stub that throws an exception, so that I can test that an interaction against another mock object actually happened. So to create that, I created specifically another fake logger, but I could have used the earlier one just to make things a bit more readable and to separate them out. So I created a class called fake logger, implements ilogger. It has the same logic that I had before. It saves the text that was sent, but it has another public field, which is of type exception, and it has logic inside the write method that says, if someone set an exception on me, I will throw that exception by default. That's all there is. Now, why am I not using properties? Because there is no need. This is a test class. It's part of the test. I want it to be as simple as possible. Properties only complicate things, and there's no need for a property. I'm not doing object-oriented work here. I'm not encapsulating anything. I'm just creating some sort of a utility stub here. So I'm calling it fake. Why am I not calling it stub logger or mock logger? Anyone have any idea? So I can use it for different ideas, for different things. Because if I call it mock now, and someone uses it as a stub, it becomes confusing. And that's why when people say, oh yeah, I'm going to mock this, and then I'm going to mock that, and I'm going to mock this, and whatever, all I hear is, so you're going to assert against this, and that, and that? And people who are familiar with this terminology also get confused. But there is starting to be some sort of known idea. If people say, yeah, I'm going to mock it out, they really mean I'm going to stub it out. So there's a simple terminology that I offer. It's called everything is fake unless you use it as a mock. By default, it's a stub. That's it. Now there are other types of terminology. Let's see how this is used in a test. In the test itself, I create a fake web service as well, another class that implements that interface, and that class just saves the message that was sent, in this case, to a web service. So my requirement here is that if you cannot write to the log, you send a request to web service that says, the log could not be written to, please do something. This is what the test might look like. Let's look at the name. Is login okay? When logger throws an exception, then it writes to the web service. Notice the name. The name is really important. If I see this test fail, I want to know. I don't need to debug it to see what the problem is. I know what is not working. So I create that fake logger, but this time I'm initializing it with an exception. And I'm saying, look, when someone calls you, I want you to throw a new logger exception. So I'm just setting a public field. Second, I'm creating that mock service. If you'll notice, the names of the variables are stublog and mock service. If you are making tests, then the reader of the test, if you're doing a test review, it's easy to spot if you have more than one mock. Otherwise, you have to go and see if there are any asserts and so on. It's just an interesting way to say, this is what what I intend to do with this object. I'm going to assert against it, so I'm calling it a mock object. This is the act part. I'm creating the new login manager. This time, this is a login manager that takes the two requirements. So I created a new type. I'll just show you the code here. This is the constructor, takes two dependencies. And this is the code that I want to test. Okay, try to send something to the log, but if you catch a log exception, I want it to write to the service. Also write it to the console, just to see what happens. Let's just remove the writing to the console. I don't care about that for a second. So, back to my test. I create that login manager, and I call isLoginOK. And the assert, notice that it's against the mock service. I'm asserting that the message being sent to the service was indeed what I'm expecting it to be. Got exception. Let's see this test in action. I'm using test-driven to run the test. It's a free add-in if you use it for personal reasons, and if you're using it in a company, you're gonna pay for it. Let's put a bug just to see if the test fails. Let's put here U and run the test again. I just put a shortcut to run testdriven.net, so every time you see this black screen, it's just the output window. I just changed the colors, so you see all the output from test-driven in the output window, and the test still passes. Why is that? Because this is not what I'm testing. No one noticed, huh? Pair programming, yeah. Okay, let's change it here. Got, you know what, Norwegian exception. You know what a Norwegian exception is? You got an error. It's like, so you got an error. I'm sorry. You got an error. It inherits from quiet exception. Okay, and now we actually have a failing test. Expected got exception, but I just got a Norwegian exception. I couldn't hear it, so I don't know what to do. Okay, let's fix the bug. That's basically it. So we have stubs and we have mocks. There's usually only one mock per test. You can have multiple stubs. Now, in complicated systems, and I'm sure you know about your system, you can have a lot of dependencies that you would like to stub out. I can think of, classes with tens of dependencies easily. And those classes are usually really, really scary. I think everyone has seen that scary class in their code that it's like hundreds of lines of code. It does everything in the system. If you remove that class, nothing works. you don't know how it works. It's like God. You don't know why it does what it does. You just trust it, and you know it works in complicated ways. If you want to fix a bug, you don't know how to fix the bug. You don't want to change the real code, so you copy paste. You take the existing method, you put it another method, you call it the same method number 2, and then you call that. I guess it's just me. And what we're trying to do with these unit tests is to remove that fear. Okay, so the terminology that I offer is that we have fakes. Everything is a fake. And you either have a fake which is a mock or a fake which is a stub. That's it. Now if you look at real terminology, like hardcore terminology, like a book in XUnit test patterns, there are at least 5 words for a lot of these. There's test spy, test double, fake, mock, stub, and there are a couple more. And each one of them means kind of the same thing, but does things a little differently. Some of them mean it just saves data. Some of them mean that it also does some logic, or that it implements part of the system, and so on and so on. Frankly, I don't care. I don't care because I want people to get into the habit of writing tests and not get bogged down with terminology. So just think of it as fakes, which are either mocks or stubs, and when you want to, you can get down into the nitty-gritty and start dividing them apart. But to get started, you only need to know the one on the left. Forget about this for now. Now, what I just showed was the manual way of doing mocks and stubs, and I just call them manual fakes. First of all, there's the problem of maintainability. Just imagine having an object with an interface with a lot of methods that you now need to implement and save the data for all of them. You change the amount of parameters. Now you have to go into the manual stub or the manual fake, and you start changing all the code in there to start saving it. Also, you can't handle multiple calls very easily unless you start writing real logic inside it. So there's a lot of repetitive logic that you have to start writing in manual stubs. Consequently, I think that manual mocking and manual stubbing is great, actually very simple for simple scenarios. And I have to say that about 50% of the time I use the manual way. It just sometimes makes code clearer. But sometimes you don't have a choice and you have to use what's called a mocking, or what I call an isolation framework. And now you understand why calling it a mocking framework is confusing, because it's also a stubbing framework. You don't just create mocks with it, but it's already so rooted, it's really hard to read it out. Just as an example, Robert Martin talked about solid design. I think he has a talk about that today, or already did. And if you have complex interfaces where you can do manual stubs on very easily, you can treat that as a design smell as well. Say, oh, this interface is too complex. Maybe I should wrap it up or refactor it into a simpler interface. So if it's hard to write manual mocks and stubs for your interfaces, you can definitely choose to treat that like a design smell. And it will better your design. But it should be your choice. So isolation frameworks, and I call them isolation frameworks because we are trying to isolate the unit under test from anything around it, allow us to get over the fact that we need to create things manually. And they create things dynamically. They create fakes dynamically, and they automatically save all the calls to those fakes for us. And then we can choose if we want to verify that calls happened on them. And if we do, that means that they are mock objects. Now, some of those frameworks actually have the word mock and stub inside the API. And they behave differently. For example, one of the most used frameworks, Rhino Mocks, has the word stub and mock inside it. And stubs, by default, can never break your test. That is, even if you try to verify on something that was wrong on a stub, it will never throw an exception. That's because it's a stub. By default, it's a stub. It will never break your test. Only mocks can break your test. I can see a song about that coming up. But only mocks can break your... Never mind. But there are various frameworks out there. There is actually a mock framework inside NUnit. Did you know that? NUnit mocks is actually built into NUnit. It's not designed to be used publicly. That is, it's there, but it's only for internal testing. But it's really simple for learning purposes. So you can start using NUnit mocks, and I'm going to show a demo of that, just to see what it looks like, what it feels like. NMock was one of the original porting of JMock, which is a mocking framework, isolation framework for Java. And if you'll notice, the name of my company is TypeMock. And in a way, that's good and bad, because I don't think TypeMock is already relevant. I would have called it TypeFake now. But it's already a brand, so. And there is the TypeMock Isolator, which is another isolation framework. There's Rhino Mocks, there's Mock. Now, by order of usage, Rhino Mocks, then Mock, then Isolator, then NMock. And the reason is that the first two are open source and free. The third one, our framework, is commercial, actually costs money. There are differences between them, and I'll show some of the differences. And you can get to see all the differences for yourself. So let's see what NUnit mocks looks like. We're going to repeat the same test over and over with each different framework. Oh, Jesus Christ, the noise here is amazing. Maybe later. We're going to show them some real noise, maybe later. Okay. Okay, NUnit mocks. So this is the simple test. Because I'm using a framework, I don't need to create manually create a class. What I create is something called dynamic mock. Now, to use these frameworks, you just add a reference to a DLL, and suddenly you get these things. So dynamic mock, I call it mock log, and I initialize it as new dynamic mock, and I give it the type that I need it to be. That I need to be faked. And sorry if all the terminology is kind of confusing, so I'm trying to stick to what I believe in, and then I mock and fake and all that stuff. So just throw something at me if you think it gets too annoying, but only after the talk. And then remember that we said that we want to have we wanted to verify that a method was called. Now, the way you do it with NUnit mocks, what was it? Let me just zoom it for a second. I think it broke. Let me start it for a second. By the way, this is a great application called Everything. You can find everything on my computer in about half a second. Okay. There we go. Master your tools. I have to tell the fake object to expect something. Once you tell it to expect something, you tell it to have either some behavior or to save that value for later. So I'm telling the mock log, which is just a dynamic mock object, to expect a method called write with the following parameters. Just one, yo. That's how I initialize it. Now I create a new login manager. That's the original one with just a mock object. And I pass it in the dynamic mock thing. It has a property called mock instance. And that holds an object. But magically, that object will implement the correct interface that I told it here. Okay? So when I cast it to the iLogger, it will magically cast to iLogger and actually behave like an iLogger. And I don't need to create that class by myself. That's pretty cool, saves us a lot of time. And now this is the same test I had before, is login okay? But instead of asserting that some message is correct, I actually wrote the assert to check here. Now I'm just saying execute that assert that I wrote earlier. So expect is like I will assert on this later. Verify on that mock log just tells it to verify all those expectations that I've set on it. So with mock object frameworks or isolation frameworks, you can create multiple expectations on an object. Multiple calls expected, multiple behaviors. You can make mocks that also behave like stubs, that will throw exception, but you can also verify on them. It gets interesting from there. I don't have to have just one assert here. Now I can also, there's also a method here called verify all. Verify all is a remnant of the old way where you would have multiple mock objects and you would want to verify all of the expectations on all of them in one method call. Then you would have verify all. But the best practice here is, even if it's supported by the framework, and Rhino Mocks has support for something called verify all, and Mock has support for something called verify all, and Type Mock used to support this until I removed it. You want to only verify on one object so that you know you're only testing one thing. So let me just quickly, for those who seem a bit dizzy, I created a dynamic mock so I don't have to create one manually. I told it to implement this interface and to expect this method with these parameters. Then I sent the instance that it created for me. It actually generates code under the covers, compiles it, if you will. It does it at runtime. It generates IL. I call isLogin OK, which should have written to the log. And now I can call verify here. So that should actually pass. Let's just make sure it passes. It passed. Let's see what happens when it doesn't pass. Go to isLogin OK. I change the string, run the test. You can see that the interaction has failed. Expected string length 2, but was 4. String differ here. And you can see that it's for somewhere inside NUnit mocks, the call stack. The interesting thing, if you want to look just deeper, it actually creates something called a remoting proxy that looks just like the real thing, but implements different code underneath. If you ever wanted to see how you can create your own framework, it's pretty cool. Let's see the more elaborate example, where we have a mock and a stub. In this case, I actually create two dynamic mocks. One of them will be a stub, one will be a mock. To the log, I say, okay, expect and throw. Expect a method write and throw this exception. Now here's the catch. If there is a parameter, I have to specify what parameter value has to be passed in for it to throw that exception. It will not throw on any parameter value. It has to throw on that exact parameter value with NUnit mocks, which could be a problem later, because let's say I don't know the specific string, but I know it should contain specific number. So I want to say only if string contains, then throw. And the other frameworks do support that kind of thing. That's called parameter constraints, where you can check only if a constraint is true, then you can throw something. And we have another expectation. This time it's on the mock service. So this is the thing that I will later verify on here. All the rest is the same test. I send in the stub logger and the mock web service, and I call isLogin OK. And I verify on the mock service. That's it. Let's make sure that works. Where's the output window? View. Output window. I should really learn the shortcut for the output window. Is it Control-Alt-O? Let's see. Control-Alt-O. Oh yeah. See, I just learned it. I just got better. Let's see what happens if I throw an exception. If I have a bug, let's go to isLogin OK, and let's not call the service. What happens when there is an expected call that's not performed? Failed. Not all methods were called. You see, that's a very simple way of saying that, and that's it basically. So we can check interaction without creating manual mocks and stubs. Okay. Now there is a notion of such a thing called strict mocks. Strict mocks, or strict stubs as well. I call them just strict fakes by default. Are those fake objects that only expect what you tell them to. If you are doing something to them that was not expected, that you did not prepare them for, kind of like my son. If you don't tell him like 5 hours in advance, look, you're going to go to kindergarten today. So don't, it's going to happen. Don't worry. If you just take him to kindergarten, he will say, no, he goes crazy. So he's kind of strict. I want him to relax. Now, with strict mocks, you always have to tell them in advance what's going to happen. Otherwise, they start screaming and break your test. So by default, mocks in NUnit are not strict. But I could make them strict by saying mock service strict equals true. You do not want to do that. As a best practice, strict mocks are usually not a good idea. And the reason is, you don't care what happens in your code, what other internal calls happen on your stubs or your mock objects. You only care about a specific end result. If some other calls happened in the on the way, you shouldn't care about it, because strict mocks care about every call. And if they break, if you just change some internal thing, but the end result would still be okay, they would still break your test. So that's why strict mocks are what's called overspecification in the test. That is, by having strict mocks, you actually specify, when you shouldn't, how the internal behavior, not only the end behavior, the end result, how all the calls against that stub or mock will happen. And if anything goes unexpectedly, your test will break. And when mocks are not strict, they will just relax. They don't care about all the other calls. You just ask them about a specific call. Did that happen? I don't care about all the rest. Did that happen? Tell me yes or no. He said, dude, totally happened. Don't worry about it. Okay? Oh, no, that call did not happen. There were many other calls, but I don't care. So that's the difference. Always use relaxed mocks. I think it's a test smell to actually have strict mocks at all today. But the frameworks used to support them because it used to be considered a good idea to verify all the interactions, even on stubs. Okay, verify that there was a call. If we look at the previous example, where are you? Okay, if we look at this example, I actually told email sender to expect and throw when called, and verify only on log writer. But it used to be best practice to verify not only that log writer was called, but also that email sender was called. And I don't care that email sender was called. It just so happens it's called in this case, and I'm throwing an exception. But tomorrow it could call 1,000 different things, which would throw the same exception and it would still work. I don't want my test to break for something that is internal. Only for external results do I care that it breaks. Strict mocks will break on both of them. Okay, so we had strict, and all the frameworks today support strict and non-strict, except Isolator, which by default is non-strict. There is no strict mode unless you specifically assert on a specific call only on parameter values. The other thing to notice is that NUnit mocks is string-based. You tell them to expect a specific method by writing the method in a string. So it's not maintainable. If you change the name of the method, the string will still stay there. And so your test will break because that method is not there anymore. So you're going to get an exception. So the new frameworks that came after that, most of them have what's called a type-safe way of handling that kind of stuff. Let's look at Rhino Mocks and how Rhino Mocks would implement something like that. Now, there is a whole session only on using Rhino Mocks. I'm not going to get a whole lot deeper, but the last session here in this theater is by the guy who wrote it. That's Allende. I think you can hear him in the background. He's a brilliant guy. He has no life whatsoever. So he generates a lot of code. I think if ever he got a girlfriend, we would all be lost. Okay. Is login okay when called writes to log. Now this time I wrote AAA here, and the reason AAA is written is because there is a pattern forming in the isolation frameworks called AAA. Just like in regular unit test you have the range act assert. People wanted to follow the same idea, and I think it was Rhino Mocks who was the first to do this. And Oren said, I want to be able to arrange but not say expect. I want the asserts to be in the end just like everything else in a unit test. And that's what you can do with Rhino Mocks. Here, we also generate stuff dynamically. There is a static method on mock repository called generate mock, but this time notice that it's strongly typed, it's generic, so it returns something that automatically implements iLogger. Now it doesn't work the same way as NUnit mocks. The API is a bit different. You get something like iLogger, but Rhino Mocks adds extension methods to every object. So the assert that we see in the end is actually an extension method on object. So this is a mock log, which is just an iLogger, and suddenly it has this method, which did not exist earlier. That's part of the Rhino Mocks namespace. Everything has an assert was called. You just need to know on which object to call it. Now, notice the type safety here. This is a lambda construct, or just an anonymous method, if you will. How many people here are familiar with lambdas? Okay, at least half the people are not. So let me refactor this into something more readable. How many people are familiar with anonymous delegates? Same people? How many people here are familiar with just delegates? Okay, same people. Never mind. I'm just going to use ReSharper to turn this into an anonymous method. If you are used to using anonymous delegates, this is what it looks like. Assert was called, and you actually pass it in a delegate. And in the delegate, it takes a logger, an iLogger as a parameter, and you call logger.write. So it's kind of a bit complex the first time you see it, but it's a great way. I think it's a very innovative and a great way to say, I'm using this method in a strongly typed manner. So if I'm going to refactor it tomorrow, my test will change as well. And of course, I'm going to have IntelliSense when I call it with all the parameters. So this is a delegate. If you will, I could have just done that to a named method. So assert was called on action. This is an action that takes an iLogger, and you call iLogger write. Now this is not a real one. It's just a fake one that the framework generated for me. 10 minutes. I got it. Thank you. Like 5 people in the audience just went like this. Thank you. As I said, quiet but nice. Okay. Let's turn that back into lambda. I can turn it into a logger. And this is what I have. I create the mock logger. I instantiate login manager with it, and I assert that this actually happened. Let's make it like this. Oh crap. Never mind. There we go. And I asserted that this happened. So I only, in the end, I can tell if something failed. This is the same thing with the mock and the stub. Notice that there is a generate stub and there is a generate mock method. And again, a stub will never break. So I say stub log, and this time I tell it to throw an exception. It has another extension method that says expect. Again, you give it a delegate. Expect a call to logger write, but throw this exception. It's all on the same interface API. Then I generate the mock service. I initialize is login okay, and assert that service write was actually called. And I think that's much more readable. I think that's great. It's a great way to think about it. Let's look at the same thing with Isolator. With Isolator, there is a simple API, different from the other. Actually, I wanted to show mock as well, so let's show mock before that. Mock has a different API, so again, you need to learn the same thing. To generate a mock with mock, you create a new mock of iLogger. And that mock also has interesting methods. For example, just verify. And again, it takes that same delegate. So it's just more concise. This is the same test where I tell it to throw. So create a new stub logger. And notice how the mock is actually very confusing. You say expect X write, where X is a logger. I want you to throw the logger exception. Okay. Then create a mock service by just creating a mock object. And this is kind of like NUnit mocks, where it has a property that returns an object of the same type. But this time, because it uses generics, the object is already casted to an iLogger and an iWeb service, so I don't need to cast it. And then I call service.verify that this happened, kind of like Rhino Mocks. Another simple API. And with Isolator. Isolator has just one entry. It doesn't use extension methods. Always starts with the word isolate. Fake instance of iLogger. And you get back an iLogger. And if you want to verify that something happened, you just say isolate.verify was called either with exact arguments or with any arguments. And then you send in the actual call to the real fake logger. Notice, if you've noticed and you are not asleep, no, what are you doing? If you're not asleep yet, that there is no parameter here. We are actually using the real objects from our test, which I think is more readable. Now the main differences here, for example, I can say isolate when called, and again fake logger.write. By default it's non-strict and it doesn't care about parameters. So called with any parameter will throw new logger exception. If I wanted to take into account parameters, I could say with exact parameters or with specific constraints. And then the assert or the verify was just isolate.verify. Always starts with the word isolate. So it should be easy to remember. Was called with any arguments. Fake web service.write. Now the main differences between this and other frameworks is that Isolator works differently in a technical manner. So it can actually fake out things that don't implement interfaces, things that are sealed, things that have private constructors, and so on, which are things which the other frameworks cannot do. They have to work within the object-oriented rule set. Isolator works differently. It works using a profiler API, so it can do basically whatever it wants. Here's an example of a login manager that has the same logic, but everything is static, which is kind of like what happens in a lot of legacy applications today. You have this class called static logger, and you call write. And if you get an exception, you call some static, maybe web service or whatever, and you get the exception and you call that web service. Now the question is, how do you test this? You probably the design here kind of sucks. You could refactor this into a more testable design, and you would get a better design. But sometimes you can't, or sometimes you don't want to, or sometimes you really like the design because it does fit the specific application requirements. Here's an example of how you would actually test this with Isolator. Let's see. So this is what I do first is that I say isolate fake static methods on static logger. And now static logger, I can just check if a method was called. I call isLogin OK, and I verify was called with any arguments. And I just call the actual static method in the action itself, in the delegate. So I don't need to send any interface or whatever. I just say, was this static method called? And it does actually check that. Let's just check that this happens. Let's run this test first. I want to show you that it actually works. For people, when they first see it, they think it's kind of doesn't make sense. Let's remove the call to write. So now it doesn't actually call a static method. And I'm going to run the same test where this should have happened. I'm going to run this test. No refactoring needed for this thing. And you can see that my test actually fails. Was expected but was not called. Static logger.write. So this will work with static methods. Of course, it can change the behavior of static methods just as easily. So I can say look, when someone calls a static method, I want you to throw an exception or return a custom value. And like that, you can take over a real system even if you cannot touch the design. And that's a real value, especially if you are in a transition moving into unit tests. So you can get good code coverage and get into a better design phase later. But this gives you that thing in the middle that you need to support you as you write tests on untestable code. Here is something a bit more scary. What happens when you have this? In your code, there is a new relogger.write. That happens too, not static, you just say new. Well, one of the things that Isolator can do is it actually take over future objects that will be created. So you can say, let me just remove this. Hey, you guys in the front, you're loving this, right? I can just say, I can create a fake logger here. Isolate fake instance. And this time, it's actually a real logger, no interface. And I want you to swap the next instance of this class with my fake. So when someone creates new for the first time, they will actually get the behavior. All the methods called will be redirected to the fake one. And then I can actually check that the fake logger was actually called. So again, if I actually do this, let's say that I want the real logger in the future to throw an exception. I will say isolate when called on the fake logger will throw an exception, and then swap the next instance of this class with the fake one. That's it. I created a fake, now I want it to be injected automatically later, not inside the test, but in production code. And if I actually run into this code, I can say, I can run any code, even if it has future objects. I'm not going to run with this too much, just to show you that this is actually possible. So you can do a lot of other cool things. It's just an example, and this is one of the reasons it's a commercial product. It does many other things, and it helps other types of development, not just a single development where you have a specific way of working. It supports multiple ways of working. Okay, I think we have just about time for a little song, and then we're done. What will be the song? Okay, this is a cool song, I like it. I need a volunteer though. You, sir, my friend, what's your name? Stefan? Can you give a warm welcome to Stefan? Don't fall off. Whatever you do. You know what to do?
I think so.
Should I tell you? Ah, but he can get a shipment of a book. You see, I have contacts with my publisher. No, seriously, he will get a book. But I didn't promise a book, did I? Can you hear my guitar? Can you hear the guitar up there? Okay. This is just a small explanation. You know, as soon as I finish the words on the slide, you just press space. Okay, don't yet. This is from a real project I was in, and it got cancelled at some point. But we were convinced that we can do everything. We were so optimistic. Everything that was asked of us, we would have done. You remember when people ask you, can you do it like half the time? Yeah, I think I can. Yeah, sure, I'll do it. And then you don't. You just don't do it. You just try, and you don't sleep, and it's horrible. So this is about not facing reality. Okay, go. When I was just a new team lead, one of the clients came to me. Will we succeed? How much will it cost? Can we finish in half the time? Yes, of course we can. Whatever you ask will be. The future is known to me. What you ask will be. The second week, the project ran. The client called and told me this. I changed my mind. We need something else. Can you change it? You're the man. Yes, I think we can. If we work really hard, we will. We'll work nights and ignore the pain. Please don't change your mind again. On the 10th month, the client called, said that he's moving the project abroad. We're running too late, we're doing it wrong. It seems like this is our fate. Que sera, sera. Whatever will be, will be. The project moved overseas. Que sera, sera. Thank you very much, guys.